new. Other than I did play around a little more with these new Vane Axial motors. Let's start here until some people get connected. I'll show you one of these motors I took apart. Circuit board, I think I tossed. Yep. All this junk that's down here. Oh, nope, here it is. There's some glitches, with these things. But they're working it out. But it's no shortage of trying, though. This is one of those German-sounding names. EBP MAPST. That brand right there. Get the brand right there. There, that's the brand right here. You'll see these in like the train precedent units. Now the carrier with the Vane Axial fan here. Some other brands, you'll see these kind of high-tech permanent magnet electronically controlled motors, like an Axial fans for outdoor, coils, condenser fans, whatnot. See sometimes the direct drive ones for reverse incline pitched, blowers, different air handlers, and package units and whatnot. So that's the brand that's in the new Train FC and GC line. So, it's similar to ECM motor that's been out since the 90s. The ECM 2.3s or whatever they're called, and then the newer ones now we have the X13 style and stuff like that, but they all work similar. So this is basically three connections. Think of it as three phase, but it's DC permanent magnet, and just like one of those other ones, if you short any two wires together, and you will be shocked if you grab these and you turn them, so it actually puts up some pretty high voltage. It'll like put the brakes on. See, when it touched, it locks it up. So it's pretty interesting. This thing I welded on here like months ago because I was, for shits and giggles, was spinning it with like a drill with my electric impact, I think is what it was, and spinning another motor or whatever with the power from it. I was just screwing around. No, I had it hooked up to a subwoofer. That's what it was. I think I put the video up. It's pretty nuts, but screwing around. So here's the bottom part. The board sits in there, and these units come like this with it all put together, and it looks about like that. Then you put your housing and your fan blade, which I'm going to get to show you guys now that I have one here in a few minutes. But let's just start with this here. So this is like the inverter drive board. It's all built in. Here's someone yelling at the dog we got. I was farting around trying to get this to work because it exploded. I think that might have been a current limiting resistor or something that was down there. It might have been couldn't tell what it was. Could have been a diode too, probably, maybe for charging it up. So yeah. So that was the outputs. This is the plug that goes. There's a lot of pretty cool tech in these. They have rubber gaskets, like O-rings here when you put the cover on. And the wires all connected right here to the plugs. And this you can see the heat sink. These wires I soldered on there a little bit, but it kind of just sat down there like that, and then the wires for the motor just came out, and it all went together like that. So I've actually ran this on different things. I mean, no doubt, I bet you if I took a module from an ECM blower and hooked up these three wires to the plug, it would run. I'd have no doubt that it would. Might not be the matched, for the winding inductance and all that kind of stuff and everything else, but it would work. So anyway, I've had that. I got a motor, which I started messing with like a week or two ago, but then the other day someone had this, and then they said somebody had scrapped a unit, and they had this, so I took it. All the screws were out of it, but I actually found some screws to kind of fit down in there. I kind of just put this on here because this thing is like a single stage jet engine. It's pretty badass. So basically the way these work is there's only one plug. It's a 9-pin plug that goes in these things. They're super easy. 2 5/16 screws. You pull those out in one of these rooftop units, and you unplug that plug and pull off the high temperature for your 24 volts right there, and it pops out. Then you just take these 9 screws out. First you got to take this off, which is just pushing in these little tabs. This all the way around. I mean, these are the easiest blower motors you're going to change in a long time. Okay, this comes off. I do have a power hooked up to it, by the way, but I'm careful. So 9 screws there. This comes off, and then there's just 4 screws, and the motor pops right out. It's way better than a belt drive. You guys are gonna change these suckers in minutes, like minutes. It takes like 15-20 seconds to get it out of the unit, and then just a few minutes to take it apart. So you got high voltage that goes in. This is a single phase one, so I got 230 going in. It'd be 3-phase on the bottom, so it's the bottom 3 wires or 2 wires on single phase like this. And these top 3 are your low voltage DC. The DC comes from the inside of the motor. So part of this is a 10-volt power supply, and it sends 10 volts back out. So you got common, which is white. You got 10 volts, which is orange, and then your gray is your signal. It's like a 2 to 10 strategy. Basically, it might be like a 1 to 10 because I kind of saw it spin. I put less than 2, but that's basically what it is. So that gives it a reference. These motors and the train precedences work the same way, but this makes its own 10 volts, and then you could go through a potentiometer or through the electronics on their circuit board to tell it how fast to run, and you can just calibrate it, and then or you could send it in from a 2 to 10 volt control source. So right there's 10 volts, but I want to change this over to the input. It's kind of hard to do this one-handed. I'm probably stab this in right here. And if I give it like 2 volts, I notice it goes up slow. Yeah, remember I said just a little over volt it'll be running. Let me turn it down a little more. There must be like my little potentiometer. There's a little lag when I turn it, and I think what it is it's just the time for the capacitor inside to charge or discharge. But I only have 1.3 volts right there. And that motor's running. A little mini jet engine. It's like that looks cool, doesn't it? I actually got that on pretty straight. It's like a 1-stage jet engine. It's got this fixed stator, whatever you want to call it, like the aluminum part here that guides the air at an angle coming out. Let's stop this. And then this blade goes counterclockwise, and it pushes the air down, matching, I guess it kind of goes to the angle of that stator or whatever. And it's like, it's pretty fast fan. It's got a lot of blades. You'll see this on some, it's kind of similar to some of the chiller outdoor air fans and stuff like that. So let's turn it back on. Oh, this is a lot of lag when I just barely turned it. There we go. So it's running. There we go. I hit the wrong button, and somehow it like changed on YouTube. It said sign in or something, which is weird, and then it exited, but luckily I was able to resume. So anyway, see that Za camera, I don't know, my glasses on, air and heat services here. He's always the first one in. He must have this thing like alert his phone when we start videos. So I probably wish I could do a different frame rate. You can kind of see that it's changing as I move the angles, just the artifact of the frame rate of a camera and the rotation of the motor. But it's going pretty fast for me having the motor go as slow as it could get. Now, I'm not going to do that when I crank that up. So 0.9 volts. See, it's actually spinning with the volts going that slow. So it's more like a 1 to 10. So I go like halfway on the potentiometer there. 5.1 volts. It's starting to like, it feels eerie when you put your hand there. I don't advise anybody to do this. Just disclaimer. And it pushes you out pretty fast. If I try to crank this sucker, it's like a freaking jet engine. You can feel every hair on your hand. And it feels like you don't keep your hand stiff. It feels like it'll suck it right in that sumbitch. Well, you've kept better track than I have on how many subs. When I first had this channel going, it's kind of loud. The channel first was growing after I made it in 2008 and like 2012, 13. I actually had almost as many subs, and then I kind of didn't do anything with it for like a while. And I went to this one facility, and I was only putting stuff up every once in a while. But I put some cool stuff once I got kind of using the channel again, like some boilers and stuff I was working on, cooling towers. And then when I went back out in the field, then I was starting to like upload regularly again. But this thing's pretty cool. I just wanted to make a kind of nice, just to make a live video so I don't have to like edit or anything later. But so, yeah. turn the speed up with this here. Hopefully I don't drop the phone on this Sunday. It feels like it wants to rip the phone out of my hand. I wish I had a tachometer, you know, a laser tachometer or whatever. Dude, put a marker on that and see how fast this thing's really spinning for RPMs. I think the sheet might actually say what it is, but I'm not prepared to look it up right now. I'm using the phone for streaming, but meter just unplugged. But you guys got the gist of that. So these are cool fans. There's a couple glitches with some of them kind of having issues. It seems to happen a lot, like after, like right when somebody turns it back on. And I don't know if it's just an inrush current. I think this has a relay. Yeah, it has all. Yeah, it's definitely going to do the controlled charge method of the capacitor. Oh, by the way, I made a video about this before. Where the F is the capacitors on this? Used to seeing, you know, capacitors, you know, like those inverter boards I just showed the other day or whatnot. So I think it's I don't know, I've never seen one that's just a black box like that. But I think that's it. I don't have my yeah, 14 microfarad. It's gotta be more than that. Come on. But anyway, or it does some voodoo and this thing does not need to have a flat DC bus, and it actually you know, when you got your power coming in, this was a 3-phase one, so 1, 2, 3, 2 fuses of the 3 legs coming through. That's it, just taps off of the right off the freaking rectified sine wave of the incoming power. I don't know. I've never really gotten to figure this out. I haven't taken apart a good working one to measure like what a DC bus might be. This might be a more than a 2-sided board too. It might only be 2-sided. I don't know. It might be 3 or something. Who knows? So you can see the 3 legs goes. Yeah. So here's the thing. The 3-phase goes through. It's got 3-phase filtration, more 3-phase. You know, to get the transients or whatever off of the 3-phase power, and it goes directly to this. You know, you want to call it like, you know, the inverter section, IGBT or MOSFETs or whatever's in there. It could be rectifying, like the rectifier could be built in on this one, and then it goes to a capacitor. But there, see, here's a relay, but it doesn't seem big enough for what this is doing. So that might be for something else. This is a mystery to me. 14 microfarads just isn't what you expect for a capacitor, and that thing says 14 microfarad on it. Can we zoom in? And it doesn't want to focus, does it? Focus. Or trying to screw with the camera to get it to focus on there, but it says 14 microfarad on top of that. 1K1, whatever that is. Just not components I'm used to seeing. So it's a mystery. This is definitely different than what we're used to seeing on the inside of electronically controlled motor. The Goodman bashing ones, oh yeah. You gotta remind me to bash Goodmans more often. I mean, this, even when this thing's fast, it's still quieter than a Goodman, even though it's scary. Do not send that video to OSHA. I'm not working in any official capacity right now, though, so they don't have anybody to go chase. But these things are basically made for 2-stage. I think what Carrier calls staged air volume. So you adjust it for your full CFMs for the capacity of the unit, 5 tons, 2,000 CFM, whatever. But then when it's not on second stage cooling or on heating, where it's going to use full speed, if it's just first stage cooling or fan only, then it just runs it's different settings, but like, you know, 66% basically is a common setting for something like that. And your amperage, of course, is like goes way down. When you use when you drop your blower from 2 to 2/3 of its full speed, it's not 2/3 of current. It's probably like half, maybe even 40% or something. Don't really have enough wire to kind of put a meter on there right now, but yeah. So anyway, don't really have a whole lot to show other than just farting around with this thing. I don't know what to do with it. Well, I think I did have one idea. Besides, if I had two of these, I'd slap them together and make a 2-stage jet engine out of it, just for fun. But I'm thinking of taking the outlet and making like a nozzle cone on it, and maybe put some brackets to put it on like a little hanger thing outside on a big steel pole or something, and like put it outside, 10, 15 feet from the my little gazebo area, and then like hook some of those misters up on the outlet on the high pressure side of my mister pump, and like then I could aim it, with the thing, and aim it towards the area where people would be hanging out, and it'd be like shooting that high velocity, high pressure mister, like they use at theme parks or whatever, where they have long lines and they put those big freaking like fans, out that blast. They have the, a bunch of misters hooked up under high pressure. Those things actually work pretty good. They like cool you off standing there. It's a nice. So it'd be funny to make this into one of those in the backyard. And I bet you, if I sealed some of this is the only openings right here, probably not much. This motor itself is pretty waterproof. So probably just throw like when I'm not using it, throw get a small barbecue cover or something and throw it over it when it's not in use. And then I'm using it, just pull it out and kind of aim it and turn the misters on and crank the fan up, put a potentiometer somewhere, mount or something on the device, and I'll have it unplugged. But it'll, might not have to turn up to full speed, but it's not quiet. And I don't know if it'd be a little quieter if I had it outside of the garage, but I definitely wouldn't be able to have it sitting too close where we're at, or it'd be too loud. It'd be annoying. It would approach, the noise issues of a Goodman. So, let's see. Got a couple guys that just jumped in, except for I'm just almost done. Monsoon sprayer, yeah, pretty much something like that, right? I did a live stream the other day. I think it was outside farting around with yeah. Oh, you go to the last video before this one. You guys are gonna like that one. But you might have got somebody else told me they were watching it today, and evidently there's two people I know that watched it that turned it off before they got to the Eureka part. Because I guess might have been boring them. But about 2/3 way or so through the video I put out before this one, I'm farting around with those little inverter boards out of that tall 2-fan Carrier mini split unit. And I found out that those boards were still good. And then I'm trying to fathom how the hell I had that explosion that I had when I was trying to put that homemade Frankenstein unit together, right? I think the title was like Frankenstein's not dead, he's just injured or something like that. Anyway, I had this explosion and it blew up my little boards that I made, I don't think any of them here, but I had made those, etched some circuit boards, and I made those two little small ones that took past the 330 volt DC along from the VFD that I tapped off the DC bus and it went over to the other inverter board. Worked in here through this transformer. I found out just when I was reading this voltage, by the way, yesterday, that this thing wasn't even putting out 240. It was pulling out like 180 or 190 or something. That, all the extension cord and everything, I think when it was charging the DC bus of the other capacitors, it was fine. But when I plugged my Frankenstein outside directly to the twist lock, it goes boom. And what it was charging up capacitors. Those two capacitors, they weren't that big, but they were in there. Was too much for the etched circuit board I made on that machine. And I had like a 1/2 inch long, pretty wide traces, but 1/2 inch long. They acted like a fuse and they popped. It made like somebody shot a 12 gauge next to my head. Boom! And flash and everything. Like, what the hell? And it blew up the VFD that I was getting the power from. And then I'm like, what? I looked for short. I put the other board in there. Boom! So, and then after that, I didn't really try much. I was going to try. I tried like a external rectifier and like a separate power directly to it. And I put a couple fuses because I was afraid and it popped the fuses. But popping the fuses makes sense because when you put power right to some capacitors, it pulls as much current as your circuit can pull. Pretty much, it's like because capacitors are very low, like internal resistance, compared to like a regular battery or something else. So it when the capacitors are not charged and you put 330 volts to them, it's like lots of current, as much as it could flow to them, and then the current quickly drops though once capacitors rise up in voltage. But if you've ever plugged a regular ECM in, I have a bunch of probably some ECMs over there in that stack over there. You plug in a regular 120 volt furnace up in an attic or wall, and I hate this Zoom thing. It does this every time. You plug a cord into a air handler or furnace that has an ECM, it goes pow. It'll, like, if you keep doing it, let the capacitors discharge and plug it in, it'll leave it'll melt the end of your freaking plug because it's instant, like could be 100 amps, 200 amps, whatever your circuit can handle for milliseconds or microseconds or whatever before the capacitors charge up, drops. It's high peak current and then it drops as the capacitors charge up. The current drops. So all I'm trying to say is the traces on these homemade circuit boards I made, Amazon circuit boards, a couple traces, probably like, I don't know, 3/16 thick, maybe it might have been 1/8 thick. They exploded like a fuse. But what I realized happened, because there's nothing else damaged in the inverter boards or fans or anything, was that I had like about this much gap between the back of my board and the chassis on that thing, and when it blew, it created an arc flash, and the current avalanched. It like a plasma torch, which I have like right there. Current flows through that plasma to ground, and that's what did it. It like probably made hundreds and hundreds of amps or whatever my circuit on my house could do for brief milliseconds. And that's how I got that arc flash explosion. It was bright, it was loud like a gunshot, and my 50 amp breaker and my main panel just would slam. Boom. Tried it a couple times. Boom. It was actually shocking that it did that. But that's what it had to be, because nothing past that fried traces on that circuit board was bad. There was no ground fault in those fan inverter boards, because both of those inverter boards are good. And you'll see me using them in my previous video. So I kind of just rambled on a lot. Just a bad thing about going live. So let me back up, see what a couple of the comments are before I cut it. See, there's people asking, is he Goodman? Dr. Frankenstein. Yep. Always mess around. I was just telling somebody at work, I said, hey, somebody else, I said, if you have any, certain electronics or whatever, sometimes just let me know. You're tossing, let me know, because, I was talking about certain kind of tech, saying, I might want it. Which I keep too much of it sometimes, but. Can I turn on full blast? You didn't see it on full blast. Let me do it one more time. Okay, here's the plug. Now listen to it. When you plug it in, you hear it when it charges the capacitors in there. So, or however it's doing. Actually, this one might not do that. Like I said, it's like, let me see. And it just doesn't really do it. I think this is a different kind of drive, man, in these things. It's not like like I said, there's no capacitors sitting on that thing like your normal inverter board. I'll turn it on in a second, just so you guys know what I'm talking about when I'm talking about charging caps. Bunch of them in here. This is like an LG board, I think, right here. Look at the size of those. If you were to go, and I cut 3 of them out, there were 6. This is like a big 460 volt one. If you were to take incoming 3-phase power or whatever and connect it, goes to the rectifiers and go right to the capacitors, it would trip your breaker in a second. With 6 of these, that'd be 6,000 microfarads. So what these do, and this is a pretty good example, and this one's pretty easy board to like follow the traces and see what it does. But there's some big resistors which already stow off of the board, and some other like diodes, and what it does, the power comes through, goes through the current limiting resistors and charges up the bank of capacitors to get them off of 0 volts and start getting them kind of up. And then after, I don't know if it senses or if it's just a fixed time, it closes the relay, which was breaking 2 of the 3 legs here going into this. Then it passes the power directly, finish charging them up, and to keep, so you can follow the current when the unit's running. So all these bigger boards have that of some sort, usually. Here's I don't know what this was. It was a Carrier Mitsubishi or something, but I've cut in a lot of parts. Oh, here, now it's filters. But there's probably some relays on here that kind of do the same thing. Sometimes they don't have too many capacitors, they won't. But anyway, if you, even if you have a couple capacitors like on the like you see normal ECMs that don't have that trick of charging through a resistor and then closing the relay, you got to have a good enough circuit, you know, and heavy traces, solder, whatever, wiring to handle that inrush current. Microchannel is pretty cool when it doesn't screw up. But, all right. R134A, Hole, I think if I'm reading his name right, wants me to kick this on full blast. So, put it on slow at first. There's my little mini jet engine. Let's see if we can get some light turn on for this last segment. All right. We'll go halfway. Halfway. Not too scary. I wouldn't want to put my finger in there. Don't tell OSHA, but here's full speed. It gets sketchy. Standing next to it. Feels like it wants to suck your hand right in that. Got that sticker on pretty straight. Bit of my eyeball, so yeah, that's it. It's loud. I got to put my talking right into the phone real close. Pretty cool thing. As long as microchannel doesn't leak, you know, when you wash it, there's no stacked coils back to back. The water goes right through it. They clean easy, from my experience. You cannot like just guess when you add charge because there's not much volume, so they're critically charged units. They hold like less than half probably what a tube and fin holds, and you will stack up refrigerant pressure really quick if you put any extra refrigerant. And there are several brands of AC units, water source heat pumps, train precedent units, several stuff here in Phoenix factory. And when it's a water source heat pump or it's a train precedent unit, you didn't charge that in the field. You just installed it as a package unit. And guess what? We've had to pull out like 4 or 5 ounces, you know, like out of a 4 or 5 ton. And then it was fine. But if you didn't, they would like stack up and trip. And what happens is when you first run them, the real critical, you know, you got to let the space cool down and wait for that load to drop so the thermal expansion valve starts throttling back, pinching off. Then you get more percentage of refrigerant in your outdoor coil than you had when you started up with a high load. And if there's any extra charge, or if it's just because of how hot it is in Phoenix, that pressure will just all of a sudden, man, I've caught it once we got these digital freaking pressure, you know, testos and field pieces and stuff. Now you can sit there and record. I've caught it. It looks perfect, but then you let it run for like 20, 30 minutes and all of a sudden head pressure goes up and then skyrockets up to like 660 and trips. You pull out like 4 ounces, 5 ounces or something like that, and then it never does it again. Had to do that to like, I don't know, 30 or more brand new Aeon water source heat pumps, the ones with the aluminum chassis, and they were like the 3.5, 4 ton units with the water temperature fine, gallons per minute fine. You could put it to heat, and some of them did it in the winter, some in the summer. Those same units were tripping randomly. The guy would just reset it in his like EMS system, but he would just get these repeat trips on the same units. Went through a part of a summer and then through a winter trying to figure it out. And then once we did, I pulled that charge out. And then once he knew he had other ones, he wrote down the numbers. I went to every one of those units and pulled out like 4 ounces or something like that, 4 or 5 ounces out of the same couple models. And then didn't even look. I mean, I went to where I just kept the hose connected in the scale and just went and pulled it out of every one of the ones that was tripping on his EMS. And then didn't have a problem after that. Didn't lose the split temperatures or nothing. Just from the factory, slightly overcharged. You know, kind of weird for a water source heat pump. You know, it shouldn't matter what climate you're in, you know, as long as the water had the right gallons per minute, 80 degrees, whatever. But then like the train precedent outside rooftop units where it's hot, you know, and it's hotter on the roof than it is on the ground, I had to pull out like 4 or 5 ounces out of some units. And same thing, you know, pulled out just a little bit, didn't lose my split temperature, and just stopped getting the high pressure trips. But other than that, those are efficient. They're efficient. Units with those take less charge. Those precedent units had microchannel indoor and outdoor coils on certain models, and it'd be like a 5-ton unit that held like 3 pounds of refrigerant instead of like 8-9 pounds of refrigerant. So stuff like you guys appreciate that once your this R410 keeps climbing in price. So see if he said anything else. And the Lennox unit microchannel, Lennox is one of the ones that liked microchannel. I have a video of it. I forget what the titles, but you could look back probably, I don't know, 4 or 5 years maybe. It was a W2F moment, and I'm like, what the hell is this? And I'm looking at the schematic, and I'm seeing 2 high pressure switches on this Lennox unit. Not one, but 2. But one is a normally open switch that closes on rise instead of opens. So what they did in their infinite wisdom, and it sort of worked, but it throw you off as a tech until you realize it, they put a heater strapped in with the expansion valve sensing bulb, and when that first high pressure switch trips, which is lower than the one that cuts out the whole unit, it closes a circuit, sends 24 volts through the heater, heats up your expansion valve to open it up, and that would be like, say, if you broke a belt or something like that. That was their wisdom to keep it from tripping high head pressure. I shouldn't say break a belt, but maybe like if you belt was slipping or dirty filter or something. But the thing is, now you're going back to what the expansion was supposed to be doing, was clamping it down, and now it's flooding, so just can't win. But that's what they did, and it called it like a heater or something. But I asked, and then somebody chimed in on YouTube here and told me, yeah, they're like, that's exactly what that is. It just keeps it from, it opens the expansion valve if the pressure gets too high, because it knows there's too much refrigerant stacking up in the microchannel, and then it opens the needle and expansion valve to let more flow into the evaporator and drop the head pressure from the resulting stacking of refrigerant in the outdoor unit, outdoor coil. Pretty funny what engineers come up with. It's like, what the fuck, man? So, anyway, sound like that 2020. Oh man, yep. For a computer case, shit, you wouldn't be able to hear anything when you're working on your computer. So. All right. I just wanted to share that. I keep saying the video is over. I got some works. I might go out of town. We might go riding with this beast here on this weekend, maybe. So, might not get too much done. But I do have a couple more units to tinker with outside, and might put one of those inverter boards in a different board I etch and put it together in one of those Frankensteins just to see the outdoor fans work again when I plug it into my regular power, and then I'll save that project for after summer. Take 2 for trying to switch out that one unit. And who knows, maybe I'll come up with a little different systems. I don't know, this worked. 24 volt interface, optical isolators, my microprocessor, my LCD, my reversing valve relay, because it's high voltage reversing valve and mini splits, and then high and low for my VFD command. It wasn't too overly built, other than I had 2 power supplies, 12 volts for that, 5 for that. If I could have found one of these boards that was 5 volt coils, I could omit one of these power supplies and only use the 5 volt. I think this was good for 2 amps. Yeah, I think that's a 2 amp chip right there. You see the same part number like on train President's carrier circuit boards and stuff like that. It's pretty popular. Buck boost, whatever, or not buck boost, but buck, style DC switching power supply. Yeah, I would move a lot of air. If you were watching the video earlier, I have an idea for that, for using that fan for something, for a mister blower, a hurricane blower or something outside. And my batteries are halfway, 47.9, 48 volts is what the nominal is, so it's 55, 56 is where it tops off, so heat pump, water heater must have ran once and sucked it down. So if somebody uses hot water tonight, it'll deplete what's left in my batteries and then go to utility power. We still have to do batteries for that. I got a couple different projects. Where are they? My friend had some batteries. Oh, he was showing me some batteries that are kind of questionable, but I mean, look at the size of these suckers. But these are he said these are pretty high density units. These could deliver power like lead acid batteries. You could almost short them out in the internal resistance or whatever. It'll pretty much just hit a pretty finite amount of current it can flow. So it's there's a limit there. You have to parallel a lot of DC lead acid batteries to get a lot of current, but these suckers, man, But of course, we've seen what happens when you rupture something like that. They freaking catch fire. We shot some that weren't even fully charged, and they erupt. I shot a Samsung old kids tablet that was sitting for a while because something happened to it. There was enough charge in it that it caught fire, erupted in fire. So, all right, I'm done for real now. Get me out of Mexican Coke. Yeah, catch you guys later.